Yes, it's okay. It's fine.
לא, אבל זה קריטי, ההערות האלה צריכות להיות בשיעור הראשון של...
אף פעם לא היה דבר כזה.
לא, של ילדים על מצגת.
על מצגת, אני אראה לך את המצגת. איזה גודל הפונט, כמה שקופיות, דקה לשקט, גם.
זה מי שעכשיו דיבר גם. כולם כל הכיוון יש קרבי ישבתי איתו שיושב לידה ניסיתי לשכנע אותו שישב ממש שהוא פקק
ומה לעשות?
לא, ממש ישבתי אמרתי שהוא ישכנע אותו Hùng, you should download it. You should have downloaded it. You did. So play it. Okay.
It's better with my computer. Nãy cậu dùng cái phần mềm khỉ gió gì để đấy?
Hùng, time is running.
Yeah. Only I cut the video, so it's just
Okay.
1 more 2 minutes.
Okay.
Just about 2 minutes.
ואני אבא עדות כזה שבסורדו.
Cái này nó nói nhanh á.
סלובקית שזה גם...
Máy tính mình á. Khổ lỗi là bây giờ lúc nãy nó không nhận.
Hùng, do you have your laptop here?
Yeah.
So why waste time on this? Is it ready on Liz laptop or not?
It's not ready.
It's not ready. But, so why did you choose to do it on her laptop?
Because before I try with my laptop, it's not connect with the.
Okay, so just do the presentation and we'll do the film on another occasion or...
Don't worry. Should we start now?
You're doing the presentation and you start with the PowerPoint?
Okay. Go.
So time is going now, yeah?
Okay, good morning everyone. My name is Hùng, as you know. Today I'm very excited and honored to be here to present to you my practicums. In my practicum, I try to develop the real-time quantitative PCR. It's a non-model organism. With the support from my supervisor, Dr. Guido Winter. Honestly, I'm not successful with my practicum, but there's still some lesson we can learn from my practicum, and I think it's important for the next study. So today I'm going to tell you about some lesson. This is the outline. Some terms I use this many times in my talk, so you can look at that. To understand about the real-time qPCR, I want to show you a video so it will be very easy to understand the idea of real-time qPCR and also the idea of my practical. So the real-time qPCR is very accurate, reliable, and sensitive. And for real-time qPCR, we work with cDNA, and we can apply for many aspects of study, like a molecular diagnostic, something. And in real-time qPCR, we have like a signal, and the machine can recognize how many copies of PCR product at the end, like a real-time, and we have the result like this, and we can analyze the amounts of PCR product. And real-time qPCR, we need the CT value. It's a minimum threshold, like the minimum signal we can realize whether it's a copy or not copy. And there are two types of analyze the real-time qPCR, absolute and relative. And we want to focus on relative real-time qPCR because we want to apply for RIN's expression study. We want to see how much the gene is studied. For this example, we have two treatments, like a control and for the stress genes. And we need some kind of reference genes which is expressed all the time at the same level. And we can look at other genes like stress genes, and we will use reference genes like to compare. So we have two formations. One we will see when, like here we have the control with CT reference genes at the same level with the stress gene, but the gene we look at is different, is expressed different. We will get the different CT value, and the graph here is actually the difference in the expression of the gene we are looking at. It's better with the sound. I'm sorry. But doesn't matter, okay, we come back with my presentation here. So in conclusion, the real-time qPCR is we can cut quantitative the amount of PCR product, not only just qualitative. And it can be take a wide dynamic range of quantification. And real-time qPCR is actually a powerful technique for molecular study with many aspects of studying, especially for studying about gene expression. And one main point is, in order to apply the real-time qPCR, we need the housekeeping gene, as I explained to you before. So I'm going to talk about housekeeping gene. You can easily find the definition of housekeeping gene on the internet, like here. And even some scientific paper, they talk about reference genes. And so what is reference genes? So basically, reference genes are the genes which is expressed in all the cells at all the environmental conditions at the same level. So it's expressed, we can find the housekeeping gene which is expressed in all the cells, all the same level. And I show you some example for housekeeping gene, like here you can see the beta tubulin something. And I'm going to show you some people they are trying to study about housekeeping gene and real-time qPCR in apply for, like here we have the paper for sequences. And in this paper, the researchers, they try to evaluate the housekeeping gene for real-time qPCR for exactly the sequences, Zoster marina. And they want to focus on the stress here, the heat stress. Another paper we have here is for another sequence, it is Zoster monitoring and for light limitation. I show you another paper here is for another kind of sequences and for some stress like salinity, pH, and light condition. And even housekeeping as well studying in another species like potato here with biotic and abiotic stress. I can give you some more example, like here we have for rice and for sugarcane with salinity and drought stresses. So after I read some paper, I conclude that study about housekeeping gene is the very first and important step in order to apply the real-time qPCR for study about gene expression. Now I want to talk about a little bit about model organism and non-model organism. So, model organism is the organism is well studied. We know a lot about the organism, like genomic information is easy to handle in the laboratory, and it's short lifetime, and we can harvest it within a short time, something like that. And I saw you a very famous model organism is zebrafish and Arabidopsis. But the reason I want to mention about model organism, because our planet interest, which is one kind of non-model organism. Here, the Cyclacid Halophilus stipulacea, which is non-model organism. So because of this one is one of non-model organisms, so we don't have some advantages, which is very easy to study about model organism. In this case, we don't have the full genome sequences of Halophilus stipulacea, so it could be more challenges for me to study about the molecular study for this Cyclacid. There's some brief information about the Cyclacid Halophilus stipulacea. So Halophilus stipulacea is the main Cyclacid originally from the Red Sea and Indian Sea, and it's become the most dominant Cyclacid with among 12 species, Cyclacid species in the Red Sea. And I show you some picture. The first one is the distribution of Cyclacid in the Red Sea area. You can see here all the green color are the Cyclacid Halophilus stipulacea distribute within the Red Sea area. And here is the real picture of Cyclacid on the set date of Red Sea. And the third picture is going to be the Cyclacid in the Moth station. I give you more information. It's very interesting information. It's very newly a paper just published few years ago as the change in the global value ecosystem services. And in this paper, I download the paper, I read the paper, and I realized that the Cyclacid in general now rank third on the top of the ecological services. So that is the good reason why we should study about Cyclacid. The Halophilus stipulacea have many they are contributing a lot of biological services, and it's important species for us. But there are very few studies have done within this kind of Cyclacid. And out of that, our very few study, no study have done related to ring-time qPCR or even housekeeping gene with the Cyclacid here. So the aim of my practicum is to, for the very first time, develop the ring-time qPCR for the Halophilus stipulacea genes, and particularly for the stress, the salinity. So because of this, goal, the first step was to design and test some primers for housekeeping gene for Halophilus stipulacea. So there are some methods I use for my practicum. It's primer design, RNA extraction, remove genomic DNA from RNA preparation and cDNA preparation. But all the second, the third, and fourth methods, I use a kit bot from the company, so I don't want to talk about it. But I want to focus on the primer design because I spent a lot of time to optimize a protocol for primer design. So I want to talk about more detail about this. So primer design, the first step, I found a name from the internet, from the paper, whatever, just to get a name of housekeeping gene. What are the name of housekeeping gene? And I get the coding sequences, the CDS sequences from the Halophilus transcriptome, which is this website. And when I have the CDS sequences, I will select the same sequences from the same genes from Zoster marina. Zoster marina is the Cyclacid. We have full genome sequences from the gene bank, and I get the sequences from this website. And I use blood ends to align two sequences because I want to make sure that the genes are the same, but the sequences also are the same. So, after that, I find the acceleration boundary for Zoosphere Marina. Because the reason I have to use the Zoosphere Marina because we don't have the full sequences for Halophila stipulacea. So we try to find the same genes, the same sequences, and from the Zoosphere Marina we will get the acceleration boundary. Because for ring-time qPCR we are working with cDNA, and with cDNA we don't have the full sequences with intron, exon, we have only exon. So our PCR primer must cross an exon boundary. So if I have in my tube some genomic DNA, so the primer cannot work. To reduce the risk of genomic DNA contamination. And to give more evidence for my result, I also find the same gene and the same sequences from the rice and from the Arabidopsis from this website. I do the same thing, but I use another tool, is cholesterol omega, because with NCBI Plus, we cannot align 4 sequences. And after I have very good genes, very good sequences, I design manually one primer. I have to design manually one primer. And this is the most difficult part of my work. When I have my own primer, I use another software, Primer 3, to automatically design for me another primer, reverse primer. And to make sure my primer can work, I check it with IDT oligo. Just to check it again, if I design some primer and this can very easily make some hairpin structure, cell dimer, heterodimer. So even I don't have to sterilize the primer, but I can say with confidence that this primer cannot work, for sure. And this, after all, I designed 4 primers you can see here. And even, to show you some paper, I read a lot of paper to get a name for, and even get the information to optimize the protocol for primer design. And I already have the primer in the mold. But when to test the primer, I test with the attraction from the normal tissue, just normal tissue, not spread tissue. And only one gene that's work stably many times, which is actin genes, actin primer. As you can see, I show you some picture here. The actin primer is work really good. But other primer, they just didn't work well. And I get something like this, no bad at all. And I suggest that actin is good positive control for future experiment. And look at the reason why I didn't get a good result for other primer. This could be one reason. Look at this. I show you this one, it's very important. This picture is actually this one is an extraction. I extract from the roots, the leaf, and the rhizome tissue. But when I track the RNA quality with the bio-drop instrument, you can see the result is not so good. This one is too high. The ratio A260 divided into A280 is too high. Because if the RNA extraction is good, RNA, it should be from 1.7 to 2.0. So look at this. Maybe 2 RNA here have the good value, but this one is too high. Another thing is the ratio 260 divided into 230 is too bad. So it could be one reason. That's the RNA extraction. My RNA, they wasn't so good. It wasn't good enough to make a good cDNA, and that's the reason I I cannot conclude that another 3 primers, they didn't work because of, it's not a good primer or because of the bad quality. And another proof for this is when I found on the internet and the RNA, it should be have 2 bands. But I got only 1 band. So I didn't understand why, but obviously there's some problem here with the RNA. So here is a general of my work. So first of all, I have to design some auxiliary primer. I did. I have to attract the RNA from normal leaf, root, and shoot. I did, but there is some problem here. We can see that there is some problem here by looking at the RNA quality. Resident library, I think it's no problem because I use give it very easy. But when I test 3 primer with normal PCR, so I get only 118 primer work stably many times, but I cannot conclude that. How about other primers? I cannot conclude that is a bad primer or something. And after, there's a way I have to been through, but I didn't. After I test with normal PCR, if I will succeed, after I test my primer with normal PCR, it's work good. So I test with real-time PCR. And if I get a good result, I will attract the RNA from straight tissue, and I do the same thing. And if I get the same result, meanwhile the genes are expressed at the same level, even if normal tissue or straight tissue, so I can conclude with confidence that some primer I did is very good housekeeping thing, but I didn't. So there's some lesson for further study. For the guys who continue my work as success, they should complete the RNA extraction by either we can buy another kit from another company, or even you don't have to use the kits in order to get a good quality RNA. You can use the chemical methods to get the good RNA. But for the first step, you should optimize the RNA extraction, get a good quality of RNA, and after that you will make the cDNA library, and you test with even my primer or design some more primer. But there's very good thing we can learn from my study is I prove that 18 genes in a good positive control. So for next study, this could be easier like what I did, because now you have a positive control for every experiment. So it's very easy for the guy who's continuing my work. And here's some just very small parts of my references. And to closing my talk, I want to thank my supervisor, Dr. Guido Winter, Michelle Ala, a PhD student from Ben-Gurion University, and my friends, my sister, who have supported me a lot by the time I'm doing my practicum. Thank you so much. Any question and comment, I welcome.
I just have a comment that because when in the first you were mentioned about you didn't get a result and anything that you will make the other people, the audience can feel that this guy is not successful, but we need to listen in. That I recommend that you need to mention it when you talk about result or something. In the introduction, you don't need to mention it.
Okay. Okay.
Did you extract the RNA by yourself?
Yeah.
Did you?
All the stuff I have done by myself with the support from Michelle and the supervisor and me.
So you did the RNA with your hands?
Yeah.
Did you take the leaf and dry it before with a tissue?
Yeah.
Because the salt, because it could stop the RNA extraction to be good.
And also I clean the water from the leaves very carefully.
Okay.
Like use tissue, you put the leaf and
So, first of all, I would like to know what is your, what do you mean when you say acceptable results?
Okay. Okay, let's take it back to this one, right?
Yes.
When you try to find good housekeeping genes for one's very special plants like Halophila stipulacea, but if you give only one result, I mean only one genes, it's never a good result. You cannot publish a paper. It's like it's not. It's better if you have like 5 or 7 or 10 candidates for housekeeping genes. So if there is one mistake and the genes is not working for the next experiment, you have other candidates to cover.
So you're saying we need to have always more than one housekeeping gene?
Yes.
No, I don't think so. So if you predict like it had more than 2 or more than 3, so you going to work and going to do on it until you get what exactly what you predict.
So
Like if you think it should be 2 or 3, so and you
actually
until you get exactly that result, right?
It's when we do a research and it's very nice, we can publish a paper. And there is a paper, I have it here, I can show you. There's the paper is guys very detailed. How many is the result you have to have in order to publish a paper? I have the paper here if you want to see the paper. Oh, it's my
Another thing about you use Google searching for
Google Scholar, yeah.
Yeah, for standard evaluation, and is there any website is more reliable to prove that there's no result about your objective?
I believe that Google Scholar is not reliable. Like when we Google some genes, even I try with ResearchGate and CBI or something like that.
And
I got the same result.
other thing, until now I still didn't understand what is a non-model organism, because the first you show us model organism, definition and some example, but your next when you move to non-model organism, you just show us example. You didn't give any definition.
Here we have the definition for non-model organisms.
But you go too far and you didn't mention.
I'm sorry because I'm worried about the time. So it's really.
Okay, and
here I show you.
thanks.
Asthelature.com. I think it's a reliable website. So non-model organism. I want to read for you. You can read by yourself. Here we have the definition.
Okay, thanks. Nothing about your references. I know you to get when you doing your practical you read a lot of references. Not the previous slide.
Which slide?
References.
Yeah, you showed your references in the middle of your presentation.
No, it wasn't references. That was examples of papers that I've done. It's not the same like a reference.
Here. Wait. Maybe you mean this one. Here, right?
Yeah, but it's not references.
No, wait. Here I just want to show some paper. What are you talking about?
Is it important for you to...
Okay, you can finish it. It was very good presentation. I want to say that for me it took me to do a good RNA when I start my PhD here. Something like 6 months until I got RNA that I could work with. So it's happens sometimes. This is science.
But I can tell you optimistically that Shara, the third school student, she's gonna continue my work, and I share to her all my experience about this work, and I'm very confident that she can finish my work within few months because she is working in the MOF with the huge town, a lot of advantage for her to continue. It's possible, yeah, it's possible. It just need more time.
Yeah.
And even it's very good news. If she can finish my work good enough, and even she can publish a paper, because I read a lot of paper. They just like what I have done.
Stay more.
Stay more.
Thank you so much for your answer.
Wait.